This is my topic. I'm a PhD student here. My area of interest is artificial intelligence, specifically natural language. I've been working with John and Andrew, who you met before. My topic, in a nutshell, is quite simple. If you can imagine a primitive environment, very basic, and in that environment you have a group of cavemen. And my goal is to get these cavemen to learn by themselves, to cooperate, to then develop language, and to be able to develop the ability to continually learn, to keep going, to push, to check if there's a boundary to learning. The question you might ask is, why focus on language? Because AI, there's movement, there's tactics, there's a whole bunch of stuff. But there's what's called the dwarfing effect when you think about language. When you pick up a concept, a word, it changes your worldview. It allows you to look at the world differently, and then you actually learn more about the world, and it's an ongoing, powerful process. So part of our human intelligence is we have language. We can layer concepts, we can build upon concepts, we can exchange concepts really quickly. So that's why I'm focusing so much on language. Alright, so as an overview for this presentation, I'll start off giving you a background of where I'm coming from this, some of the background research, and why that kind of led me to think why I think this will work. I'll then talk about what I'm trying to do to take a little bit further. So with the background, foundational research, and then what exactly I'm doing. Alright, so when you think about AI, there's basically two types of AI. There's first type of AI, the one that we're quite used to, is what I'm calling designed AI or engineered AI. That's where we take what we know, we program it in code. Now, we can program it in code normally using if-else or case statements. So if you take, for example, Half-Life 2 or Unreal Tournament, which you've just seen, it's just a huge body of case statements, selections, encompassing AI. The other type of AI is Emergent AI. And I think I may have chosen the wrong picture as an example of something intelligent. But with Emergent AI, you don't encode anything. You set up conditions so that the AI interacts with the world and develops its own intelligence over time. Some of the basic tools, so those are the two types of AI that both have their pros and cons. With the designed AI, its advantage is you can get started really quickly. If you have a specific type of behavior you want, you can get it, you can program it and get it. But then you come to a barrier where you can't extend it to past a certain point because it gets too costly, it takes a long because the code base grows and becomes very complex. With Emergent AI, it's the other way around. You have to spend a lot of time to start setting everything up, but then it goes by itself. Alright. Now, in terms of what research has been able to do, researchers have been able to get agents to develop their own language. It's a language that actually, it's a stable language. So in an environment, they interact, they communicate, they come to common understanding, and they use the language is stable, it doesn't change too much over time. And then the researchers have been able to show that these creatures in these virtual environments have been able to benefit from having a language. It actually gives them a survival advantage. You can work together, you can share information about the world. And the next thing that researchers have been able to do, which is really important, which kind of creates a foundation for what I'm doing, is that as they create this language with this basic vocabulary, they can build upon this vocabulary. So for example, if you imagine a world of mushrooms, poisonous mushrooms, nutritious mushrooms, they can look at it and they go, purple mushroom, poisonous. And they can create a new category, poisonous mushrooms, and they can build on and on. Now, the drawback of this research, because it's still quite new, this area which is, you call it evolutionary language, is that these languages are really, the vocabulary is really small. 10, 15 words, and also the sentence lengths are really short, 1 or 2 words only. Also, the concepts they use are, we don't know how to extend it. So that's part of what I'm trying to do. Alright. So with my research, all I'm trying to do is take this research a small step further to increase the vocabulary, increase what they can learn from the world. And why this is relevant to games is that the mechanics that I'm using is quite simple, but at the same time, there's no real barrier on how far these AIs can go, as opposed to a designed AI. With an emergent AI, so the neural network that continually grows, it's up to the way you set the environment that kind of shapes how this AI will develop. Also with this AI, you shift the development from encoding knowledge to the way you set up your world, your ecology. So it's a different way of developing AI for your worlds. So, what I'll talk about now is some of the powerful things that these agents have been able to learn to do for themselves. So, here I'll show you some videos of agents learning to move and being able to compete with each other. So in this video, this agent is learning to, if you imagine a neural network inside a body with physics, and it's learning to walk over time. And part of being able to learn to walk is interacting with your world, learning from mistakes, and improving over time. So you see this agent is slowly getting it. It's testing its body, moving back and forth sideways, learning its center of mass, and it gets better and better. And it develops a bit of a swag. Alright. So that's some rough research. Now, this research has been taken and used in some commercial games. This is some middleware which came out of Stanford University, and it's been used in some rather large games, Grand Theft Auto 4, the latest Indiana Jones, Star Wars: The Force Unleashed. Now, I won't show the whole video, I'll show you some. Some of the parts which I find quite interesting, which we'll talk about here. Alright, so this engine is called Euphoria, and with the way we set up the agent's body, so they've created a skeleton with muscles, and with some neural network evolutionary algorithm, and with lots of behaviors. So with this behavior, you can interact with the world in quite powerful ways. It has instincts for self-preservation, you can adapt. Okay. So that's some of the basic behavior what this engine can do. This next video shows a slightly more advanced behavior with the same engine.